Moon. The sole natural satellite of Earth is the Moon. It makes up the Earth-Moon satellite system with Earth. Its diameter is roughly equal to that of the Earth, comparable to the width of Australia. It is the largest satellite in the solar system and the largest, and most massive, satellite of a planet in relation to the planet. It is also larger than any known dwarf planet. According to the geophysical definitions of the term, the Moon qualifies as a satellite planet since it is a planetary mass object that developed into a distinct rocky body. There isn't much of an atmosphere, hydrosphere, or magnetic field there. About 1/6 of Earth's gravity is present on the surface, 0.1654 g. The only satellite in the solar system known to have a higher surface gravity and density is Jupiter's moon Io. Its gravitational pull slowly lengthens Earth's day and is the primary cause of the tides. It orbits Earth at an average distance of 384,400 kilometers, 238,900 miles, or nearly 30 times the diameter of the planet. The sidereal duration of the Moon's orbit around Earth is 27.3 days. Lunar phases, which serve as the foundation for the months of a lunar calendar, are created when the amount of visible surface illuminated by the Sun varies over each synodic period of 29.5 days from 0 to 100%. The length of a full revolution of the Moon on its own axis causes its same side, the near side, to constantly face Earth, and the somewhat longer lunar day is the same as the synodic period since the Moon is tidally locked to Earth. However, due to changes in perspective brought on by libration, 59% of the entire lunar surface is visible from Earth. The Moon is believed to have formed 4.51 billion years ago, not long after Earth, from the debris of a massive collision between the planet and a hypothetical Mars-sized body called Theia, according to the most widely accepted origin theory. After that, due to tidal contact with the Earth, it retreated into a larger orbit. Dark volcanic maria, sometimes known as seas, are present on the Moon's near side and cover the voids between bright, old crustal highlands and large impact craters. By the conclusion of the Imbrian epoch, some 3 billion years ago, the majority of the big impact basins and mare surfaces were present. The reflectance of the lunar surface is just somewhat brighter than that of weathered asphalt, making it comparatively non-reflective. The full Moon, on the other hand, is the brightest celestial body in the night sky due to its huge angular diameter. Due to their nearly identical apparent sizes, the Moon can fully block out the Sun during a total solar eclipse. The prominence of the Moon in the Earth's night sky and its predictable cycle of phases have served as cultural touchstones and influences for human communities throughout time. Language, calendars, art, and mythology all exhibit these influences. The Soviet Union's Luna 2 unmanned spacecraft was the first artificial object to orbit the Moon in 1959. Luna 9 made the first successful soft landing on the Moon in 1966. The Apollo program of the United States, which put 12 men on the Moon's surface between 1969 and 1972, has been the only one to date to send humans there. A thorough geological understanding of the Moon's origins, interior structure, and subsequent history has been developed using the lunar rocks that these and other uncrewed missions returned. Mysteries of the Moon. What we still don't know after Apollo. We last went to the Moon 50 years ago, and we haven't been back since. In that time, we've sent robotic spacecraft out into the solar system and discovered new planets. Scientists are still thinking about the rocky visitor to our night sky in the interim. The Apollo missions made it easier for us to understand many of the Moon's mysteries, but many more remain unexplained, including a few that were brought about by the samples the Apollo astronauts brought back. The Apollo evidence has given rise to a number of scientific questions, according to Roger Lanius, a former NASA chief historian who spoke to Space.com. Going back might be beneficial for a variety of reasons, including gaining new information and more content. 10 things you didn't know about the moon. Scientists reiterate that the moon still has many mysteries that need to be investigated as NASA gears up to send men to the moon once more by the year 2024 and amid conflicting messages from the U.S. administration over the impending mission. Sarah Noble, the Apollo Next Generation Sample Analysis Program executive at NASA headquarters in Washington, told Space.com, "We have a lot of excellent questions. Over the past 10 years, a lot of items have been placed in the moon's orbit, providing us with a worldwide perspective." Noble continued, "Now we know where to look for the answers to these problems." Water was discovered inside rock samples brought back from the moon by the Apollo 15 mission, nearly 40 years after leaving the moon. The 2009 discovery, which raised the possibility that water may have existed on the moon since its formation, opened up a completely new field of study for the moon. Future space exploration will depend on water being present on the moon, since it might be utilized as rocket fuel and drinking water. "We believe the samples were entirely dry for 40 years, according to Noble. We now recognize the existence of the water cycle, but we do not comprehend how it operates. Although we may not fully comprehend the water cycle at this time, we do have the means to do so." Paul Hain, an assistant professor in the Department of Astrophysical and Planetary Sciences at the University of Colorado, told Space.com, "From my perspective, we have all kinds of sensors that didn't exist before." Hain said that because of their recent miniaturization, instrumentation are now simple to incorporate into spacecraft. Recent studies has revealed that the moon may have ice in addition to water. The north and south poles of the moon have frozen soil, according to a 2018 research. The issue of ice and the poles is the one in which Hain declared himself extremely interested. "We want to examine this and would like to know where and how much ice there is. Gather fresh information to research this." According to Hain, modern equipment like infrared instruments that can identify the chemical fingerprint of ice, thermal cameras, and other heat-sending devices can be used to find the ice on the lunar surface. According to Noble, while the majority of the basaltic rock samples returned by the Apollo missions were old, some were discovered to be as recent as 1 billion years old. Scientists estimate the moon's age to be 4.51 billion years. Although scientists are aware that volcanic eruptions have happened on the lunar surface, they are still unaware of when these eruptions took place and when the moon ceased to be volcanically active. It's kind of a popular topic, but there are still some questions regarding how active the moon is right now, according to Hain. In addition to not knowing when these volcanic eruptions finished, he continued, "We also don't know what started them, such as whether a massive lunar impact or the moon's radioactivity was to blame." A 2014 report opens a new tab, and Nature suggested that heat-producing elements like uranium, thorium, and potassium are driving the lunar surface to expand and contract as it grows hotter and cooler. Recent research has shown that moon rocks are rich in radioactive material like uranium. This procedure would have created surface fractures that would have allowed the lava to flow through them. Hain suggests that scientists should update their theories on the moon's volcanic activity because many of them assume that it has long since ceased to be active, despite the fact that some scientists think that the moon is still tectonically active. The age of our moon is likewise a subject of discussion. Estimates range from 4.5 billion years to a much younger 150 to 200 million years. According to Noble, scientists have tried to determine the moon's age by examining the lunar rocks that Apollo astronauts brought back and by attempting to determine when the craters on the lunar surface formed, but there hasn't been any agreement so far. "It's a significant question that we want to address," Noble added. But Noble emphasized that it's also important to determine the ages of other rocky planets and moons in the solar system, including Mercury and Mars. By comparing the number of craters between the moon and Mars or Venus and the moon's age, we can infer the age of other planets. The rocky body's age is correlated with the number of craters on its surface. We will eventually have a better understanding of other planetary objects in our solar system that we desire to explore by gathering as much information as we can from the moon. The moon, she claimed, can assist us comprehend how to live and function on another body, say, for example, if we go to Mars. Lunar scientists reiterate that it is vitally essential that we do it for the sake of future space travel and to learn more about our own planet, despite the continuous discussion about whether we should return to the moon. As a lunar scientist, Noble expressed his excitement about the science that can be conducted on the moon. "We currently intend to strike the moon before moving on to Mars,"